Hello, so in the previous video we have discussed about how to convert NFA to DFA. So in this we are going to discuss how to convert NFA with epsilon to NFA or DFA. So coming to the question, this is the given question. Q0, Q1 and Q2 are states, 0, 1 and 2 are alphabets, and this is an epsilon transition. So first we will be drawing the transition table for this. Q0, Q1 and Q2, 0, 1 and 2. We already discussed, right? For the initial state we will be keeping an arrow, for the final state we will be keeping a circle. So 0, 1, 2. Q0 on 0 gives Q0, Q0 on 1 gives nothing, so 5, Q0 on 2 gives nothing, so 5. Q1 on 1 gives Q1, it doesn't have 0 or 2, so 5 and 5. Q2 on 2 gives 2, Q2 on 2 gives 2, 0, 1 nothing, so 5 and 5. So we won't be writing an epsilon transition, we only consider 0, 1 and 2. Okay. So now let us find out how many number of transition functions do we have to write in this. So it is calculated in the form of number of states into number of alphabets. So Q0, Q1, Q2, there are 3 states, 0, 1 and 2. There are 3 alphabets. Do not consider epsilon as an alphabet here. So 3 into 3, 9. So we will be having 9 transition functions. Okay. So now let us also find the e-closure values of Q0, Q1 and Q2. So for finding e-closure values, what we have to do is we have to check the path of the epsilon. So for Q0, for every transition we will be writing the self state first. So e-closure of Q0 will be having Q0, e-closure of Q1 will be having Q1, e-closure of Q2 will be having Q2. So coming to this, Q1 on epsilon is going to Q1. So we will be writing Q1 here. And from Q0 we have epsilon transition to Q1 and also to Q2 indirectly, right? See, so we will be writing Q2 also. So for Q1 we already wrote Q1, and let us check the epsilon transitions from Q1 now. It has only one transition, Q1 to Q2. Yeah, done. So Q1 has Q2 too. So for Q2 we will be writing self state first, that is Q2. Does it have any epsilon transitions from this, like towards right of this? No. Or else does it have any epsilon transitions backwards? No. I mean, it is from Q1 to Q2, not Q2 to Q1, right? So we do not write those transitions. So for Q0 we will be having for Q0 we'll be having Q0, Q1, Q2. For Q1 we'll be having Q1, Q2. For Q2 we'll be having Q2. These are the e-closure values in the transition table of this. So now let us write the transition functions. So Q0 on 0. So Q0 comma 0. Okay. This is a first transition function. E-closure of e-closure of Q0 comma 0. So first we'll be solving this. Okay. E-closure of Q0. What is e-closure of Q0? We found it as Q0, Q1 and Q2. So we'll be replacing this with that. Q0, Q1, Q2. This is the formula, by the way. Here we will be writing the state and here we will be writing the alphabet. So Q0, Q1, Q2. We got it like this. So let us split this. Q0 comma 0 union, Q2 comma 0 union, Q1 comma 0. We can write it this way. Dou of Q0 comma 0 union, Q1 comma 0 union, dou of Q2 comma 0, right? Now what is dou of Q0 comma 0? Q0 on 0 gives Q0, Q1 on 0 gives 5, Q2 on 0 gives 5. So we will be having Q0 union 5 union 5, which is nothing but Q0 only. So the final output is e-closure of Q0, which is nothing but Q0, Q1, Q2. So the answer is Q0, Q1, Q2. The same way we will be finding Q0 comma 1. So the same formula, e-closure of dou of e-closure of Q0 comma, here it is 1. Okay, this is 1 comma 1. So what is e-closure of Q0? We found it as Q0, Q1, Q2. So Q0, Q1, Q2 comma 1. Again we will be splitting this. Dou of Q0 comma 1 union dou of Q1 comma 1 union dou of Q2 comma 1. What is Q0 transition function of Q0 comma 1? Q0 on 1 gives 5, Q1 on 1 gives Q1, Q2 on 1 gives 5. So we got 5, Q1, 5. So what is the union of these three? Q1. So E-closure of Q1 is Q1 comma Q2. So we got Q1 comma Q2. If you find this formula a little tricky, then you can also do this. First, just find out the transition function of E-closure of Q0 comma 2. So state comma alphabet. What is the E-closure of Q0? It is Q0, Q1, Q2. So first do the inside function. So let's split it. Q2 comma 2, Q1 comma 2, Q2 comma 2. So what is Q0 comma 2? 5 Q2. So 5 union Q2. We'll be getting Q2 as the output. Now let's just take the closure of Q2. That is nothing but Q2. So the same way we'll be calculating transition function of Q1 comma 0 and Q1 comma 2 and Q1 comma 1. Like Q1 comma Q2 comma 0. So Q1 comma 0 union Q2 comma 0. Through the table we'll get as 5 and 5. So E-closure of 5 is nothing but 5. So here E-closure of Q1 comma 1 and E-closure of Q1 is Q1 Q2. So transition function of Q1 comma 1 union transition function of Q2 comma 1. Q1 comma 1 is Q1, Q2 comma 1 is 5. So E-closure of Q1 is Q1 Q2. The same way Q1 comma 2 E-closure of I'll be taking E-closure of this whole thing at the end. So E-closure of Q1 comma 2 is Q1 Q2. So Q1 Q2 comma 2, Q1 comma 2 union Q2 comma 2. This is 5 union Q2. We'll be getting Q2. So E-closure of Q2 is also Q2. The same way we'll be finding Q2 comma 0 as well. So here you can see Q2 comma 0, Q2 comma 0, we'll be getting 5. And the same way Q2 comma 1, which is nothing but 5. So we'll be getting 5. Here we'll get Q2, E-closure of Q2 is Q2. Now we got this transition table of NFA without epsilon using the transition functions like we got, right? Q0 comma 0, Q0 comma 2, Q0 comma 1, and here Q1 comma 0, Q1 comma 2, Q1 comma 1, Q2 comma 0, Q2 comma 1 and Q2 comma 2. We wrote all the values in that below transition table. Now using this transition table we can easily draw this. So now this is the new transition diagram that is obtained. Okay, so in this do we have any epsilon transitions? No. So we successfully converted NFA with epsilon to NFA. In the previous video we have discussed how to convert NFA to DFA, right? Watch that video for further information on how to convert NFA to DFA. Thank you.